Okay, we're going to look now at sampling. We're into the section now where you'll see almost no actual quote math in terms of arithmetic or anything like that. This is all more what you would see in a science or humanities course. And so you need to approach it that way. You really need to think about reading. You all need to read chapter 5 by the time we're finished with the chapter. It's going to really help you with your understanding because this is all going to be explanations and logic. It's not going to be any numbers in this section. Okay, so let's start with the concept of sampling. First of all, why sample? Okay, and the idea is that we often want to know something about a group of individuals, but we cannot collect data about all the individuals. So there's several reasons that might happen. Sometimes you just lack resources. Okay, you might lack the money or the time to study every single individual that you're interested in. Sometimes you don't have the manpower to do it, human capital. Okay, sometimes you can't find all the individuals. Right, so if I want to study all the people in the United States, the time, the money, the number of people that would take is almost unwieldy, and sometimes you're not going to be able to find everybody. Okay, so that's why we sample. We take a small group instead of finding everybody. And sometimes, you're going to try to sample everybody, but some people aren't going to want to be part of the sample. Okay, or are going to be, if it's not people, it's sometimes objects, right? Sometimes you just can't get those objects. Okay, it's pretty hard to sample all the fish in the sea because you just can't get to all the fish. Okay. So there's two definitions here. The first is a population. In the context of statistics, a population is the larger group about which we are interested. And that's as opposed to the sample, which is the subgroup who you actually collect data from. So my population might be all Americans, and my sample might be 500 Americans who became part of my study. Okay? So the population is this concept. You can't always actually even get everybody in the population. It's not even possible. But it's the population about which you want to know something. And the sample is the group that you actually get in order to learn about that population. So, Zogby, which is a telephone survey, or used to be, I think it's still around, you call 382 Republicans to find out who they're going to vote for in the 2011 nomination for president. Well, this is a little outdated, obviously. I updated some of it. I forgot to update some others. Again, the population is all Republicans because they were only calling Republicans. But the sample was the 382 Republicans who actually answered the phone. Okay, a census is another concept here, which is when the population and the sample are the same thing. So a census is when you ask everybody, and it was in the population, or you're able to collect data about the entire population. That is a census. Okay, now there's a problem here, and the problem is that individuals become undercounted typically. Okay, it's just. It's not impossible, but it's incredibly difficult to actually take a true census. We don't do it very well in this country, and there's a lot of debate about that. Okay, so census is a nice idea, but not really practical. Okay, so the whole point is we want to collect data from a sample that is as representative of the original population as is possible. Okay, and so we need some more definitions here. Numbers which summarize a population are known as parameters. So those Greek letters we use, mu and sigma, those are parameters. They describe the average age of an American, okay, perhaps, or the standard deviation of Americans, of ages of Americans. That's a parameter, okay? Describes the population. The sample is the statistic is the number that describes the sample. So my sample of 500 Americans might have an average age of 32, okay? That's my X bar, as opposed to whatever the actual population age is. Okay, so X bar and S summarize a sample, whereas mu and sigma summarize a population. Mu and sigma are parameters, and X bar and S are statistics. Okay, and then we should think about it this way. If a sample is representative, what do we expect of our statistics? Well, it's pretty straightforward. The statistics should be close to the sample, to the population, to the parameters, pardon me. So the statistics, X bar, hopefully, if everything goes well, should be close to mu. S should be close to sigma. Okay, so if our sample is representative, we hope that the sample statistics are similar to the population parameters. Okay. So for a sample to be representative, it must be similar in makeup to the population. So we were talking about the word representative. Now let's talk about how can you actually get that. Okay, suppose we want to find the average commute time to work in Washington, D.C. How would you go about sampling it? Now, we can think about this lots of different ways, but let's just think about who would we ask and how would we ask it. Those are the two main questions. And the last thing I want to say here is, how do we know we've done a good job? The whole point is we were trying to figure out what the average commute time is. So at the end of the day, how do you know if you have a good sample if you don't know the answer to the question? Okay, it's an interesting question. We're going to come up with some ways to approach that. So there's a couple things we need to worry about here. Bias can be introduced into your sample. And there's two kinds of bias. The first is personal bias, right? I'm biased against people with hats. Okay, I don't like people with hats. That's not true, but that's a personal bias that someone holds. That's going to affect your work for sure. When I talk about bias in this class, though, I'm not talking about personal bias, okay? I'm talking about bias in the study, okay? If I go and I ask people on Metro, how long does it take you to get to work, okay? Might be a good study, except that my study is biased towards people who take the Metro. I'm not talking about people who drive. I'm not talking about bicyclists. I'm not talking about walkers, right? So bias in the study is what we're talking about when we talk about bias in this class. I don't want you to tell me that why was the study bad because the person is racist, right? That's hopefully that's not true, but in the context of statistical analysis, we're interested in what it is about the way that we did the study that brings in some kind of bias into what we're talking about. Okay, so how do we reduce bias? How do we reduce this kind of bias where where there's some kind of institutionalized favoring one thing over another? The Metro example, where I favored people taking the Metro to people walking or bicycling or driving. Okay, so how do you choose a representative sample? How do you reduce that bias? Okay, how do we choose a sample that does not reflect our biases, right? And the answer to that is randomness. Okay, it's a pretty straightforward answer. The idea is that if every sample has the same likelihood of being selected, okay, so you go and you want to sample 300 people, if you make sure that no matter what, those 300 people are all randomly selected, then at the very least, it's not your fault if they're not, if it's not representative. Okay, you did the best you can by removing yourself and removing all the biases that are inherent in possibly the study or your personal biases from it by making it completely random. That's the whole concept. So first of all, let's talk about what random events are. What is random? We don't have a good, human beings cannot do random very well. I'll just say that right now. Okay, an event is random if all the possible outcomes are likely to occur. Now, here's a great Dilbert cartoon that I really like, and it's a tour of accounting. You have your monster that's a random number generator, and he just has nines all over, right? And Dilbert says, "Are you sure that's random?" He says, "Well, with randomness, you can never be sure, right?" So just because things are evenly distributed doesn't make it random. Okay, randomness is something human beings are extraordinarily bad at. Okay, we'll talk more about that in class. So our gold standard for a random sample is something called the simple random sample. Okay, and here's the definition: a simple random sample of size n, okay, is a simple random sample. Pardon me. If every possible sample of that size has the same likelihood of being selected. Okay, so what's interesting about this definition is it's different from the way we do it. This is what a simple random sample is if somebody asks. Here's how you do it. The first thing you do is you number every individual in the population. If there are 2,000 people in the population, I'm going to start with 0001, 0002, 000, all the way up to 2,000. Okay? And so we're making sure that every number is the same number of digits. So if my largest number is a 4-digit number, every number is a 4-digit number. Okay? Then what we do is we're going to use a random number table, and we're going to look at this in class, and we're going to begin in an arbitrary place in that random number table. Okay, so I decide arbitrarily I'm going to start at line 15. Okay, that was not a random selection. That was an arbitrary selection. I might have a bias towards the number 15. Okay, but by doing that, by arbitrarily selecting line 15, I don't know what's in line 15. The first number is random. Okay, because the random table is made of random numbers. Okay, we'll talk about that in class more. So we use that random number table, starting in an arbitrary place, and we read numbers of the same length, discarding numbers outside the range and duplicates. So I read through in 4-digit chunks. The first 4-digit chunk, the second 4-digit chunk, the third 4-digit chunk. And all I do is I go along and I select however many I want in my sample, okay? And I go through and I discard any number that's outside of the range. So if I'm going from 0001 to 2000, any number that is bigger than 2000, I'm just going to skip over it, go to the next 4-digit chunk. And I'm going to go until I get enough things into my sample, into my bag, as I want. Okay, we're gonna skip over discard numbers outside the range and duplicates. I'm not going to select person 1,882 twice. Okay, and that's it. That's a simple random sample. We're going to do some practice of those later. Okay, so here's just a quick example. So we want to find out something about the student body. Okay, there's almost always a change in the master schedule every year. So we're talking about perhaps if there's a change next year. What do we think about that? So we have resources to talk with 80 students, and the student body is 580 students. So how we do use a simple random sample? Here's what we do. We number each student, okay, 001 all the way through 580. Now I actually should have gone all the way through 580, not through 415. Okay, so we go all the way through 580. Okay, every student would be assigned a number. Then we just use a particular use a table and begin at a particular line. Any line will do as long as we arbitrarily choose it. We don't always want to start at the same line, but as long as we arbitrarily choose a starting point, it's going to be okay. We're going to read from left to right, choose the first 80 students that come up. We'll discard any repeats or any numbers bigger than 581. Okay, and once we have our 80 students, we'll stop. And that's it. That's a simple random sample. So again, we number things, we pick from a random number table, and then we stop. And what that does is creates a sample, and that sample has the same likelihood as any other sample of being selected, and that's what we're after. Okay, thank you guys. Good work, and we'll talk about this more in class.